Make sure this is recording. Great. All right. Um, Again, I'm going to make the same request, and you can ignore it. It's just a request, not a requirement that people keep their cameras on, just because it's awkward lecturing to just a blank screen, which is all I'm seeing right now. Um, that's just a request to help me. You don't have to do it if you're not comfortable. It's fine. Really, just somehow it makes it feel more human when I'm seeing faces rather than just a blank screen that I'm just talking at. Um, all right, thank you. This first slide that you're seeing in this today's lecture is just a little advertisement for CS35. This is an option for, I should be for most of you. Um, Zach Dodds often teaches this in the spring. He's the one who teaches the 300-person section of CS5 in the fall. And he's great, everybody loves him. And it's really a follow-up class to this class. The next thing you would do in Python really fits nicely with what we're doing right now. So right now, we are learning how to program classes and objects. And that really increases the functionality of Python by defining more kinds of things you can do. We've seen some objects before in this class that were imported through other libraries, and we're going to talk more and more about libraries later, I think next time. But whenever you say like import math, what you're doing is importing a bunch of new objects into Python, and then you can use those objects, right? So you have these methods that come with all those objects that you've imported. So Python by itself is fairly limited, but once you import new libraries of objects, then it becomes incredibly useful and functional. And there's a couple of really common libraries that really focus on the functionality of Python. And so CS35, you're learning the functionality of these new libraries. You're not necessarily learning any new programming techniques, you're just learning new capabilities that you can add to Python. So these are some of the ones that you see that they cover in CS35. That one in the middle, matplotlib, is a huge package just for, oh, wait a minute, don't do that, sorry. There we go. That one in the middle, matplotlib, is a huge package just for creating graphs of functions and bar charts and pie charts and all kinds of things. So if you're using Python to just process data and present it to somebody else, you're going to want to use matplotlib. scikit-learn is really important for doing any kind of machine learning, which is nowadays everything is done in machine learning. So you get an introduction to that. This is why CS35 is accepted as an intro data science class for what will hopefully be Pitzer's new data science minor. It's mostly because you do matplotlib and scikit-learn, so you learn the basics of data science when you're learning some machine learning. VPython is a way to create a three-dimensional environment that you can use to program video games. And actually, next week, we're going to do some VPython assignments. We're going to do an assignment using VPython, and you're going to use some of the functionality of VPython. So you'll get a little taste for VPython next week. And then there's some other ones here. Natural Language Toolkit is for using natural language processing, taking large bodies of text and processing that and looking for various features of that text. Lots of reasons to do that. So that's CS35. So I encourage you all to think about that if you're looking for a follow-up class. I don't know if it's offered in the fall, but it's certainly offered in the spring. All right, so today we're going to build on what we did in the last two classes. So in the last class, you all built, and for homework that was due this morning, you all built your first class, which was that date class. So remember the date class, we'll go over this in a minute, has various attributes, which is the data stored within the class, like the month, the day, and the year. And then it's got methods, which give that date class functionality. In the class before, and for the homework before, we talked about two-dimensional arrays of data and making kind of a game where you can check for 3 in a row going east, south, and you did that programming assignment. So if you were to program something like tic-tac-toe, you'd want the computer to detect if one of the players won, so you're going to check, is there three in a row going in any direction? So now we're going to combine those things by programming Connect 4. And this will be our next 2 days of work, okay? So we're going to create a Connect 4 class, and we'll talk about how to do that today, and that'll be your homework assignment due next week. And then on Tuesday of next week, we'll think about just the very, very basics of artificial intelligence, how you would get the computer to play Connect 4 back against you in some kind of intelligent way, okay? So today we're just going to do another example of a class, which is a Connect 4 class. You've already done the date class. Now you'll see a Connect 4 class, and seeing multiple different classes defined in different ways and doing it yourself and adding the methods yourself hopefully just gives you a better understanding of what a class is and what an object is and what a method is and what an attribute is, all these things we've been talking about. Okay, so again, a class is a data type like int or float, right? These are data types, and you can create your own data type by defining a class. And an object is an element of that type, right? Just like 7 is an object of the int type, right? You created very specific dates that were of your date type, okay? And these are all focusing programming by breaking up your problem into the types of objects that will be useful for that problem, and then creating classes based on those types. That way of thinking about approaching programming is called object-oriented programming. And you often hear Python referred to as an object-oriented language. And this is exactly what we're talking about. You're just, it's oriented toward making objects. So that phrase OOP for short stands for object-oriented programming. The date class, just as a review of stuff you've already done, the class is your data type. An object is a specific class, right? So the date 12/31/2018 would be an object in the date class. And then you define methods, which were various functionality built into the date class, which did things to dates, right? And then you also define the representation function, which is what printed the date with a particular format. So the representation function always returns some sort of string that you print to the screen. The init function is what actually creates the date object, given the data that the user inputs. And then when you're defining methods within the class, you have to have some way to refer to the date that the user put in. And that's where you use this keyword self, very important keyword. And it's a little bit of a hard concept to get your head around, that when you're in the class definition, you've got all these methods within the class definition. Those methods are going to use the current object that the user is working on, but we don't know what that object is yet. So we use self as kind of a placeholder for that object. Hopefully this makes more sense to you now that you've done your homework and done that date class assignment. All right, so we introduce new classes and new objects to increase the functionality of Python. So if we want Python to play Connect 4, we're going to define a Connect 4 class. And that way we can create Connect 4 objects, which will be a specific configuration of the board at a particular moment in time. And just like with the date class, you had a tomorrow function that advanced you from one date object to another date object. We'll have an add move method, which will advance you from one Connect 4 object, which is a particular board arrangement like this one. And then if you say move in column 3 with a black checker, then that'll advance you to a new Connect 4 class where that move has been made. Right? So just to remind you, hopefully you all remember what Connect 4 is. Is there a picture of it? Connect 4, it looks like this. You know, it's this kid's toy that was invented a while ago. I don't know, I would say dates back to maybe the 1980s or so when they started making everything out of plastic. And it looks like sort of it's basically a combination between checkers and tic-tac-toe. So it's checkers because it's literally played with little plastic discs that look like checkers, just little red and black discs. And there is a barrier right there at the bottom that prevents the checkers from falling all the way through until you flip a little lever and then they all fall out. That's how you reset the board. Um, that so players then take turns. There's a black player and a red player, and they take turns just picking a column and dropping it in. So a move in Connect Four means you pick up your piece and you pick a column. That's all you get to pick. You don't pick the square it goes to. You just pick a column to drop it, and then gravity just lowers that piece down until it falls and it's stopped by some other piece. Okay, so all you do is pick a column, drop it, and it stops somewhere, and then it's the next player's turn. And then the object is like tic-tac-toe. Your object is to get 3 in a row, and Connect Four, your object is to get 4 in a row. Okay, so that's it. So the board is like a tic-tac-toe board in the sense that it's just a bunch, it's a grid of open cells, and then players take turn filling up those cells until one of them gets 4 in a row. Okay. The way we're going to represent this, draw this on the screen, is it's going to look like that. We're going to use, we've done some ASCII2 drawing before where we made little pictures out of characters. So we're going to do that again. We're going to just use X's and O's and dashes, and we're going to create a picture of the board, and that's what the representation function within this class will return, right? Because those X's and O's and slashes are just characters. So altogether, that board is just one big character string, and the representation creates this character string that looks like that board. So if you ask for the representation, if you say print B and B represents your board, what you'll see is exactly something like that. Just a picture will appear. And we'll see how that works in a minute. Okay, so the data that we'll need is the board itself. We'll need 3 things. We're going to need the width of the board, the height of the board, that's the data, okay? And then also where all the X's and O's are. So we're going to use X's and O's to represent black and red checkers. And we want to know where are all the X's and O's. So there's a little question on the bottom there. We want to set the blue question mark to be an X and the red question mark to be an O. Whoa, whoa, whoa. That we want to turn into an X. And this one we want to turn into an O. Okay, so the way we're going to do it is we're going to access the data attribute b.data. And the data attribute, so an attribute of a class can be anything you want it to be. It could even be another class. Or it can be like when we did the date class, we had 3 attributes: month, day, year. Okay, and those were all integers. But they could have been strings, right? An attribute of a class could be a string. An attribute of a class could be a real number, a floating point number, or a complex number. An attribute of a class could be a list, or it could be a list of lists. So in this case, b.width, that's going to be an attribute of the B object. So again, we're going to create the Connect Four class. B here represents an object of that class. Right? Object. B is going to be an object of the Connect Four class, which is just going to be a specific thing of that type, right? B will have different attributes, like date had a month attribute, and a day attribute, and a year attribute. B will have a width attribute and a height attribute, which are integers, just like the month, day, and year. But it'll also have a data attribute, which will be a list of lists. Okay, so if I want to refer to this blue question mark up here, I look at b.data, that's a list of lists, and then I use indexing to refer to that specific element there. So that's going to be in the row 0 and column 1. And if I want to set that to X, I just say that equals.
That in here is the Odyssey, is just the idea that.
Somebody's got their mic on. Okay. Okay, so how do I set the red question mark to an O? Down here. How do I set that one to an O? What do I type? Somebody put it in the chat window. Good. Max, data 4.2, almost B dot data. Okay, that's row 4, column 2 equals, and then you need quotes because O is a string. O, like that. Good. Perfect. Okay. So again, B dot data is an attribute. If you just type B dot data and hit enter, what you'll get is a list of lists that will represent the whole board simultaneously. And then if you want to reference any one element of that list of lists, you have to use 2 indices for the row and column. Okay, methods. So we talked about the data. The data is width, height, and board, right? Width, height, and data. Those are the methods. Width, height. Those are the attributes, the data members, and data. Okay. Width is just a number, height's a number, data is a list of lists. Methods, let's move on to methods. For methods, we want to understand what kind of functionality do we want to connect for object to have, right? So connect for object, again, it's just one snapshot of a connect for game. It's one board with a bunch of checkers in it somewhere, right? Just like a date object is one single date. Now with the date object, for example, we define the tomorrow method, which advanced you to a different date object. We're going to want to do something similar where we have an add move method, which allows you to add a move in a particular column, and that will transform you to a different Connect 4 board. Okay. All right. So that's an example of one thing we're going to want is add move. Right. So if you say b dot add move, now add move is going to have some arguments like a column number and whose turn it is. Is it X's turn to go or O's turn to go? So you might have an X in quotes, 4 comma X. That'll be a function that operates on the B object, and it'll do that by simulating dropping an X checker into column 4, and the result of all this will be a different object, just like the result of tomorrow is a different date. Okay, the new object will now be the new board with that checker dropped into column 4. All right, before we start any class, at the beginning of starting any class, we need the class constructor. We need to be able to set up the whole empty game. So here's the constructor. Here's how you would define a empty board. So the constructor starts with you, just the user, just defining a width and a height. And then you can set up a list of lists of blanks to represent that empty height. All right. We need to set the attributes. So that's exactly what we're doing right here is we're setting self.width. That sets the width attribute, and we're setting that to be whatever number is here. Okay. And then self.height, we're setting the height attribute to whatever number is here. Okay. And then we have to actually create self.data, which is a list of lists. So just for convenience, we're defining W to be the width and the height. You don't need to do that. You could keep referring to it as the word width and the word height because those are here and here. I don't know why they bothered to rename that a different letter. It just makes it a little cleaner to type this out here and here. So this is notation you should all understand at this point. If I take a list with a single blank and I multiply that list by W, that's like concatenating W different blanks into one big list. So that becomes blank, 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 W times. Right? That's one row of my blank board. And then I want to take that list of blanks and create a list of those things. So here we're using the list word keyword 4 there to create a list of lists, and the range function to do that h times. Okay? So this is just a nice compact way to create a list of blanks where you have a row of W blanks and you do that h times to get h rows, which means each column will have h elements to it. That was the init function. That's the constructor. That's what creates a new blank board of a certain width and height. The representation function, the reaper function, is going to print that board out. If somebody asks, if I say a particular object is B and I say print B, then I want a visual representation of this board as a string of characters. And the nice thing with strings of characters is you can output a picture using strings of characters by using this ASCII2 art kind of methodology where you actually like draw a picture using just ASCII2 characters. And the picture we're going to draw is a visual representation of the board. So here's the code you'll use so we're just giving you the code. So I want to make sure everybody understands this code. So again, we're just going to start out with some shorthand. H and W are just going to represent the height and width. You don't have to define that. You could just, wherever you see an H in the code below, you could just say self.height. And wherever you see a W in the code below, you could say self.width. But that's more typing than just typing H and W. S is just going to start out being an empty string. And you'll notice in the end, S is what's being returned. So we're starting out with just a blank empty string, and then we're going to keep adding things to S, and in the end, that's what we return. Okay? So we're starting out with S just being nothing, just an empty string. And then you see this nested for loop, this for here and this for here. So we have a nested for loop, which we saw, think about the programming assignment 2 classes ago, when we have a list of lists and you want to go through all the rows and then go down to the next row and then go down to the next row. You have an inner for loop to go across the row, and the outer for loop gets you to the next row and the next row and the next row until you've done all the rows. So the outer for loop is representing columns, and the inner for loop is representing rows. Another way to think of that is R is standing for row. This letter R stands for row, and we'll have H different rows because that's the height of this list of lists. C stands for column. I said it backwards, I'm sorry. As I go across the row, I'm going from column 0 to column 1 to column 2 to column 3. I'm going across a row. So the row is staying fixed. It's the column number that's increasing. So that's that inner loop increases the column until I get all the way to the end of the row when I've gone with W. Okay? Now what am I going to do as I go across that row? First, before I start the row, I'm going to start with a vertical bar. Let me do it in red here. I'm going to start, before I go across the row, I start with a vertical bar. That is just the very first bar right here. Okay? Then I take the string that I have, I add to that whatever the data element is at this next spot. Okay? That's what's going to go here. And then another vertical bar. That's what goes right here. And then I do it again for the next row. I look at, the next time that inner for loop runs, I go to the next column, I fill in the next data element and add the next vertical bar. And then I go to the next column and fill in the next data element, the next bar, et cetera, until I go all the way across. And the last thing I do is enter a bar. Once that inner for loop is done, I've gone all the way across the row, and then you'll see a special character that gets added to this string, the \n. Who remembers what that \n does? Anybody? You can just put it in the chat window or yell it out. We've seen it before, but only once or twice, so I'm sure a lot of you have forgotten. New line, Joey said it, good. Yeah, \n is what just gets you to the next line. Just starts you over to the next line, and then you do it again for the next row. You just go across the next row. You start with a slash at the very beginning, then you enter the for loop and do data element, bar, data element bar, data element bar until you get to the end. Then you're done with that for loop again, that inner for loop. You get to the new line, you go down to the next row, you start it again. Start with the bar, jump into that for loop, data element bar, data element bar, data element bar until you get to the last bar. You get down into that next for loop. You see a backslash n that gets you to the next line, and you keep going across. And then you do that h times, and you've gone through every row. Right? And you can see that those data elements are either blanks. Whoa, didn't want to do that. Are either blanks, or they're x's, or they're o's. And this Reaper function needs to work on any board, not just the initial board that you started with, which was all blanks, but on any board at any state of the game. So those data elements may have x's or o's, or they may have nothing in them. Okay? Now, at the end of both loops, the inner loop and the outer loop, now we've done this much of it. Those two for loops have created this much of the board. Okay, what does this line do right here? Yeah, I see Walter motioning with his hands. That's the advantage of keeping your video on, is you can give me hand motions as answers. Thanks, Walter. Yeah, so this just takes a horizontal dash, that's what's over here, and does 2w plus 1 of those. All right, and you got to think a little bit why it's 2w plus 1. So w is the number of data elements, but the number of characters we need a dash under each data element, but we also need a dash under every vertical bar. And there's a vertical bar between data elements. And then we need one more because of that one from the very beginning, which is why we have 2w plus 1 horizontal dashes there. Now, the only thing we want to print that I've circled in blue here, the only thing that is missing that we haven't done yet is the numbers at the bottom. And those numbers are nice and convenient because instead of you just manually going there on the screen and counting columns, then if you see the number there, you know, oh, okay, I want to move in column 2, and you know it's clear to you which one column 2 is. So it's nice when you print the board to also print those numbers at the very bottom, and this is being left to you. You have to think a little bit about what kind of loop you would do to print that column, and be a little bit careful because not only are there numbers here, there are also blanks. The number 4 is followed by a blank and then the number 5, just to get the spacing right. Okay, so you're going to do this for your homework. You know, almost all of this code is given to you. The only bit of code that's been left off is this little challenge of you to print those numbers, the column numbers at the bottom. Just make sure they actually line up with the columns. And to do that, you've got to add blanks between each one. It's not very hard. All right, this would be your quiz for today. So I'll give you a couple minutes to think about it. So I want you to stare at the screen here. And again, this is the add move method. The add move method will take 2 arguments, which are the column number and a string, a little single character, which is either an X or an O, representing whose turn it is to go. And again, it starts out with a convenience just defining h being self.height. You don't need to do that. Instead, where you see an h in the next line, you can write self.height, but it's a lot cleaner to just use a letter h. So h represents the height of the board. And in theory, this code will add that x checker to this. It doesn't work though. You see there in the second question on the bottom of the screen that there are some bugs in this code. So you want to think a little bit about now 2 things. Think about what happens first. This will help you find the bugs. Think about what happens if the user runs b2.addMove3, O. Right? So b2 is a particular board. They run the addMove function. So b2 is going to represent self. 3 is the column. O is the OX variable. And now go through the code yourself, that definition, and think about what happens when you run that code, okay? And you'll see it doesn't quite do what you want it to do, and then that'll help you find the bugs as the answer to the second question. And then you need to think about how to fix those bugs, okay? So I'm gonna give you 5 minutes to stare at this. Think about what's wrong with it and how you would fix it, okay? And I'll keep recording, so anybody watching this at home afterwards, you got 5 minutes also to stare at the screen here and see if you could figure it out. Give you all 1 more minute. I forgot to look at the clock when I said I'd give you 5 minutes, so I feel like you have 1 more minute. All right, let's work through it. I'll try to talk it through and hopefully you got the answer. Um, I should have pointed out B2 is over here on the right. This is B2, the thing you're looking at. So when it says run B2.addMove, you're really thinking about this particular board. We're going to be moving in column 3 with checker O. Okay, so let's see what happens. First, H equals self.height, and the height here is um, the number of rows you see, which is actually 6. So it's 6, height 6, right? We've got 6 rows. So first row, now row is going to be a variable in range 0h. So first row will be 0, then 1, then 2, then 3, then 4, then 5. Okay, so let's think about what happens when row is 0. That's what we're starting with. So if self.data row, which is 0, column, which is 3, okay, so we're looking at 0, 3. If it's not equal to a blank, then we're going to do something, all right? But 0, 3 is right over here, and it is equal to a blank. So we don't do anything, okay? Then we go to the next element of the for loop, where we advance the row number to 1. Okay, so now we're going to look at self.data 1 comma 3, which is here. And that's a blank, so we don't do anything. Okay, and then we go to the next element, which is self.data 2 comma 3, which is here. Okay, that's a blank, so we don't do anything. The next thing we do is we look at self.data of, what did I say, 2 comma 3 we did. Sorry, 2 comma 3 we did. Now we're going to look at 3 comma 3, which means we're looking at this element right over here. And it's saying if that's not equal to a blank, that's what this line is saying. If we're not equal to a blank, then we're going to go backward a row in the same column and put that checker in. So we're going to go backward a row and put a checker, an O checker right over here. Okay, that's good. That's exactly what we wanted. If you drop an O in there at column 3, then it'll fall all the way down and land right there. That's perfect. Okay. Ideally now we'd be done, except the for loop keeps going, right? Now the for loop is going to look at the next row and column and change the previous one to an O. And then it'll look at the next row with the same column and change the previous one to an O. Right? And then it stops because we've hit the last one. Right? That's obviously not what we wanted to do. We wanted to stop when we hit that first O and not keep going. Right? So that's the bug, is that it doesn't stop when it's supposed to stop. It gets to that point where it sees a checker, it backs up one and puts the O there. That's great. That's exactly what should happen. But it doesn't stop. It keeps going down and now looks at the next one. So here's how you fix it. It's a very easy fix. Is there's 2 things wrong, right? There's 2 bugs actually. The second bug is a little bit a little bit hard to spot. But this return function down here, just adding that under the if block, right? This is indented. So it's only going to hit that return if it gets to the point where it doesn't see a blank. So adding that return there does exactly what it's supposed to do. If you ever get to that point where you don't see a blank, it'll add the checker to the line before, the row before, and then hit that return function, which leaves the method entirely. And then you're done. Okay, that's great. The only problem with this code is, like here in column 5, what we would want if we dropped an O in there is we'd want it to land right there. And this code as it stands doesn't do that. So you'll go through that whole for loop where row is 0, then 1, then 2, then 3, then 4, then 5, and we'll never hit the condition that tells us to put that O there. We'll never hit that return statement. So that's exactly what this last line does. if we go through every single element of that column 5 and we never hit anything, then it must be that the whole column is blank. And in that case, we want to stick that checker down at the bottom entry, and this will be the bottom entry. The column we've picked, H minus 1, right? Because we've got 6 rows here, but we're starting counting from 0. So the last row is row 5. Okay, so we're putting it at the H minus 1 row in column 5, and that gets us this checker right there. Okay, so I hope everybody understands that return function is necessary, so it stops if it hits a checker, puts the checker there before it, and then leaves this method because we're done. And that last line is there in case the whole column is empty, it's blank. Give me a thumbs up if you found one of those bugs. Just one of those bugs at least. Cool. Awesome. A couple people chiming in. Great. All right. Another move we want before we let the user drop a checker in a particular column, we may want to first check that that's an allowed move before we run the add move function. So allows move is just going to return true or false, depending on whether or not you're allowed to move there. So all it does, you don't need to know if whose turn it is, if it's X's turn or O's turn. We just need to know, we're really just checking, is the column full? So it's going to take a column number like 0 and just say, are we allowed to move in column 0? Can we move in column 0? And that's not a full column. So yes, you are allowed to move there. All right, we're allowed to move in column 1 because that's not a full column, but column 2 is full. So we're not allowed to move there, so we'll return false. So we're returning, this is a method that returns a Boolean, which is just a true or false, right? So it's just returning true or false, depending on whether or not that column is full. That's all it does, okay? So here's the code for the allows move function, but there's a couple blanks there. These are significantly easier than the quiz questions. So I'll give you 2 minutes on this one. Think about how you would fill in those blanks. And I'm sorry, those blanks are not quite lined up with the text. So this says return false. This one says also return false. And the other one's return true. So think about what the blanks are, what you want to put here and here so that this works. And there's a little hint there that this conditional is checking, are we out of bounds? In other words, you want to return false if somebody's checking if column 8 is an allowable move. Okay, so just check, is the column number that's been requested bigger than the width of the board? That's all you're checking here, okay? And this is really where the work is, where you're checking, is that column? Now, if we get to the second, the elif part, then we're not out of bounds. So they picked a legitimate column, but in that second conditional, you want to check, was the column that they picked true, full, right? And if it wasn't full, then you're going to return true. If it is full, you'll return false, okay? So I'll give you 2 minutes to just think about what those 2 blanks should be. Ooh, there's a typo on this slide. Look, they said this board you're looking at is B3. So all of these should have been B3.allows moves, B3.allows moves, right? That I think I'm sure these are referencing this board. So the way you reference that board is you call the allows move method on the B3 object. So there's a little bit of a typo there. All those B's should have been B3s since this is the B3 object. And they say it over here. We're looking at B3.allows moves. Okay, what do you all think? What about the first one? Type it in the chat window, somebody, so you can type it the fastest. First one's quick. We're just checking are we out of bounds or not? Is the column that was entered bigger than the width of the board? Nobody's typed it in yet, or my screen's frozen. Or everybody's asleep, gone to make a snack because I only see one person's video. There we go. Max says, call bigger than or equal to W. Good. Max said, call greater than or equal to W. And we need a colon there. There's a little bit of a thinking you have to do to decide, do you want greater than W or greater than equal to W? What is W for this board, for board B3? What is W? How many columns are there? 7, good, right? There's 7 columns here, right? So you don't, but the columns are labeled 0, 1, 2, 3, 4, 5, 6. So if somebody enters 7, that would not be allowable, right? You can move in column 0, column 1, up to column 6. 7's not allowable. So if the column entered equals the width, then that would be false, right? If somebody entered 7 here, then they'd be entering the width of the board, which is 7, but there is no column 7. So greater than or equal is correct. You do want false if it's equal to W. You certainly want false if it's greater than W. So greater than or equal is good. All right, somebody else. What about the elif part? Elif, Walter's got it. Elif B3 0 call is not equal to blank. Almost good. Somebody help him. Fix it. What's he missing? Almost good. How do I refer to a particular element of a board? Ah, good. Michelle, thank you. B3.data. B3.data is referring to the list of lists that comprise where the checkers are. Good. So we've got B3.data. That's the list of lists that tells you where all the X's and O's are in the B3 board, right? And then you want to look at row 0, column COL, just like he said. You want to check, does that equal a blank? And you want to return false if it's not blank. So you want to check if it's not equal to a blank. In that case, you return false. And in every other case, right, the other cases means it's not out of bounds and the top thing in the column is blank. In that case, it is an allowable move. So we get down to this true statement in every other case. Right? So there we go. We've got our constructor we've talked about, right? We've got the allows move we just talked about. The add move was the quiz. The representation we talked about, although there's a little bit left to do to put the column numbers on the very bottom. So I'll have to do that. Okay. Couple other moves that were methods that you're going to write with your homework before we're done. You want to be able to back up one. Let's say somebody made a move and they said, oh, no, I want to take that back. Hold on. That's actually super annoying to do when you're actually playing Connect 4 because you've got to kind of force the checker up the column. It's not easy. But we can program that to allow somebody to take back their last move by making a del move method, which would remove a checker from a particular column, right? So take whatever checker's at the top of that column and pull it off, right? So that's a method you will write. Is full is you want to check, is the whole board full, right? You can do that by using the allows move to see, is every column full, okay? So there's a little hint there on the is full thing. It's not going to take any column argument because you're going to look at all the columns. You're just looking at one particular board and said, is this board full or not? Wins for, you want to check if a particular player has won. Did X win or did O win? This is exactly the code that you wrote. Let's see, what is this covering? Which core cards, which is similar, which are similar to others? I don't know what's intended there. Yeah, that wins for is exactly the code you wrote for your second to last homework assignment. Okay, the code you wrote for your second to last homework assignment, you're checking for n in a row going east, south, north, northeast, northwest. Check all those directions. I think you did actually 4 out of the 8 directions because you don't have to do west if you've done east. And what you want to do is step through the whole board and check, is there a win? Are there 4 in a row in any direction for player X if OX is X? If OX is O, you want to check, is there 4 in a row in any direction at any position on the board for player O? You've already written that code. Okay, that's the code you did for 2 assignments ago. So you've got to dig that out and somehow import it into this class as a method for this class, right? The last one is the game itself, host game. So host game, if you type host game B, so this is how it's going to work. You're going to type B, okay, and a height and a width. B equals connect 4 colon 5 comma 7. Gives you 5 row, width 5, height 7. That sets up your blank board. Then you're going to type B dot host game parentheses parentheses. And then the game will start. The computer will say, it's X's turn, which column do you want to move in? And then there'll be a prompt on the screen. And whoever is player X will be able to walk up to the keyboard and say, column 3, enter. When that player hit enters, the computer will call the add move method to add an X to column 3. Okay, and then print out the board after that's been done, right? So you're going to say B2, the next board is B dot add move X comma 3 to add that X to column 3. And then the computer will ask you, now it's player O's move, which column would player O like to move in? And then player O will walk up to the keyboard, press whatever a column number they want. The computer will then use that column number to call the add move, right? So that host game function is just going to be a function to repeatedly ask players which column they want to move in. And then we'll repeatedly call the add move function. You should add a little bit of sophistication there. Before you call the add move function, you should call the allows move function to check if it was an allowable move. And if it's not, it should print a message to the screen that says, hey, you can't go there, make another choice, okay? Once they find an allowable move, then it calls the add move function to advance the board. And a little bit more sophistication, after every player has moved, you should also call the wins for method. The wins for method will check, did somebody just make a winning move? If they did, now it should print a message to the screen that says, game over, player X1 or player O1. Now it's possible in Connect 4 that nobody won, that the board just fills up to the top and nobody won, and that's another thing you're going to check for. So after every move, you might want to also run, if nobody won, then you might want to run the is full method, which checks is the board filled, in which case now the computer will print out a message saying, game over, nobody wins. Game over, board full, nobody wins, right? So that host game function really sets up the whole game and allows the players to take turns and does all the checking it needs to do to actually simulate an actual game of Connect Four that two players can play. Right? Now, this assumes the players are playing against each other. Let me go back for a minute, and then we'll talk a little bit more specifically about some of these functions that I just described. But this assumes the two players are playing against each other. So that host game turns your computer into a virtual two-player Connect Four game that two players can then come and play. What we're going to talk about in the next class, not today, but next Tuesday, is how do you get a player to play against the computer? So the computer asks you for your choice, and then the computer makes a move and does so not randomly, but with some intelligence. So that's another thing you can do is have the computer move randomly. That's something you should all be able to pick. Just have the computer pick a random column, check if that was an allowable move. If not, pick another random column. Okay. So I'm sorry, today I have the day of the week mixed up. Thank you. Somebody in the chat window says, are we not having class Thursday? And I have the day of the week mixed up. My bad. What you're going to do between now and Thursday is program this Connect 4 class, and on Thursday, thank you, we'll talk about how to program some intelligence and have the computer move for itself. Thank you, sorry. All right, we have about 15 more minutes. I think there's only like 2 or 3 slides left, so we'll get done early. Just a little more detail. The wins for is going to check, is there a win for a particular player? And again, you've already done this when you did the 3 in a row function or the n in a row function. You're checking specifically 4 in a row here, and you know what to do. You're going to check if there's 4 in a row east, 4 in a row north, 4 in a row northeast, 4 in a row southeast, or whatever those 4 functions are doing. So you need to take your 4 in a row functions, the 4 in a row functions you wrote, bring them into this code, and you're going to call those 4 functions here on this if line. If any of those are true, stop and say, yes, this is a win. Otherwise, at the end of this, you'll return a false, saying it's not a win. And you've got to check that for every position on the board, which is why this is sitting in a doubly nested for loop. So for each position on the board, that's a particular row and a column, you'll run these 4 conditionals to check if you have 4 in a row based on that condition, that position. If you ever find that, you'll just stop and return true. And if you don't, you'll finish both for loops and return false. Okay, so there's a little hint on how to write that wins for function. In the end, once you're done, once you finish this programming assignment, you should have a good sense of why we've done all this, right? Elegance hides complexity. That's a nice little statement on this slide. To actually play Connect 4, you can use that host game function, or you can have the players just sit there and type in, is there a winner? Can we add a move? And it becomes fairly natural because we're picking natural sounding methods, right? We're saying b.addMove x comma 3. That's pretty clear that what you want to do is add an X checker to column 3 in board B, right? So you introduce this kind of natural functionality to Python. And if you set things up correctly and choose nice names for your methods, then it really creates a lot of elegance that these methods can be extremely complicated, but the user using these methods doesn't need to see any of that. Again, if you think about all those libraries I talked about that you cover in CS35 at the beginning of class, like the matplotlib library creates wonderful pie charts and bar graphs and line plots. You don't have to know anything about how those methods work. You're just going to type things like bar graph x comma y, and that might create a bar graph of data x with y columns, right? And then just boom, it just pops up on the screen. Right, so these kinds of methods hide the complexity that's going on inside the computer, and that's a good thing because you don't want the user to care, right? So this is exactly why we define objects and classes and methods and attributes and all the other good stuff. You did this yourself when you were doing the day of the week function, when you did your date class, and you probably did something like this. you said, okay, what's the difference in the number of days between two different dates? What is that mod 7? Based on that answer, you know the day of the week. Okay, so assuming you know the day of the week for date for self, then you'll know the day of the week for D2 or vice versa, depending on the answer mod 7, right? So these methods are useful to define other methods. And again, you can bootstrap this level of complexity into more and more and more complex methods by building up these methods. So again, your host game method is going to use your other methods over and over and over again. All right, that's all we got for today. So good luck on this. You've got kind of an outline or a skeleton. There's not that much left for you to do, just a couple of functions that you need to build. Where are they here? Just a few. A lot of these are like wins for is similar to what you already did. Is full is just going to use the allows move function. Del move should be relatively easy to delete a move. And then host game is just going to be stringing together all those other functions and methods in the way that I described. Anybody have any last minute questions? Otherwise, we are done. See people already disappearing from my screen. Going once, going twice. All right. See you all either in office hours or lab tomorrow or on class on Thursday.
Thank you.
Thank you. Bye.